Good morning, doctor and everyone. Today I'm going to be presenting homeostasis of thermoregulation. This is the lesson outline for this topic. First, we're going to discuss about the introduction. Second would be why thermoregulation is important. Third is main controller is the hypothalamus. Fourth would be cooling mechanisms and heating mechanisms. Fifth, negative feedback mechanisms, and the last one is conclusion. So the learning outcome is by the end of this lesson you should be able to outline and explain the thermal balance and understand the mechanism of how homeostasis of thermoregulation occurs. So first, what is homeostasis? Homeostasis is the ability to maintain a constant internal environment so that every organ and cell is provided the perfect condition to perform its function. It is a key mechanism where every organ plays a role in maintaining a constant internal environment. And now we're going to look into thermoregulation. Thermoregulation is the maintenance of psychological body temperature by balancing heat generation with heat loss. A healthy human should have a body temperature of 37 degrees Celsius. If the body temperature drops below 37 degrees, metabolic reactions become slower because molecules move slower and have less kinetic energy. If temperature rises above 37, the enzymes of the body begin to get denatured and metabolic reactions will be much lower. Sometimes the temperature of the area you are at is low enough to decrease your body temperature. Sometimes it is high enough to raise your body temperature. This is why the body has the ability to control its body temperature. Our skin is responsible for this process. Next, we're going to look why thermoregulation is important. So, the first important is it maintains optimal enzyme function. Our body's enzyme work best at 37 degrees Celsius. Too hot or too cold disrupt reactions. The second is it protects cells. High heat damage membrane and proteins. Cold temperature slows or stops cell function. The third one is it keeps body systems stable. Heartbeat, breathing, and nerve signals rely on stable temperature. And the last one is it prevents dangerous conditions. It avoids heat strokes, which is overheating, and hypothermia, which is extreme cold. So this is the hypothalamus. This probably explains the negative feedback mechanism of the hypothalamus. So, so we're going to look about the normal body temperature is 37 degrees Celsius. When the body temperature rise above normal, the brain signals dermal blood vessels to dilate and sweat glands to secrete. And next, the body heat is lost to its surroundings, which lead to the body temperature drops toward normal. And then if the body temperature drops below normal, the brain signals dermal blood vessels to constrict and sweat glands to remain inactive, which, if the body temperature continues to drop, nervous system signals muscles to contract involuntarily, which is where our bodies shivers. Next will be muscle activity generates body heat, which makes the body temperature rises towards normal, and where the body heat is conserved. This is all where the hypothalamus control all these negative feedback mechanisms. Next would be we're going to learn about the cooling mechanisms. So when the body is overheated, the body takes several actions to drop it by trying to lose heat in several ways. The first one is vasodilation. This action causes the body to lose the heat quickly. It involves the widening the lumen of the blood vessels of the skin, which increases the blood flow and rate of the heat loss. The vessels are also brought near the surface of the skin to reduce the distance heat has to travel to escape. The next one will be sweating. Sweat glands near the skin begin to secrete sweat on the surface of the skin through the pores. This sweat acts as a heat consumer to absorb the body heat and use it in evaporation. The activity of sweat glands is increased when the temperature of the body rises. Next will be the heating mechanisms. When the body temperature drops, the body takes several actions to regulate its temperature by insulation to prevent heat loss and producing heat energy. The first one will be vasoconstriction. This causes the blood vessels to become narrower to reduce heat loss. They also sink deep into the skin to increase the distance heat has to travel to escape, thus reducing heat loss. The second one will be shivering. The muscles in the limbs start to contract and relax rapidly, thus increasing in the rate of respiration and amount of heat energy released by it. And the last one would be hairs. Our hairs on our skin become erect, which where the muscles erectors contract and make the hairs erect and stand up vertically, trapping air in the gaps between them. This acts as an insulation to reduce heat loss. The second, the next topic will be real, where we're going to discuss about the real life examples. So first would be where we sweat on a hot day. This leads to where it leads to cools the body through evaporation. The second one would be where we shivers in cold weather. It generates heat through muscle activity. And the third one where our face become red after exercise. This is because the blood vessels widen where the vasodilation occurs to release heat. And the last one is where we get goosebumps during the cold weather or cold temperature. It's because it traps a thin layer of warm air. So finally, we're going to discuss about the conclusion. So first one is thermoregulation is a vital part of homeostasis, helping the body maintain a stable internal environment. By using negative feedback mechanisms, the body can correct temperature changes and protect itself. Proper thermoregulation ensures that enzymes, cells, and organs work at their best even when the external environment changes. Lastly, without it, extreme body temperatures could lead to dangerous conditions like heat stroke or hypothermia. So that is all for this topic, and yeah, thank you everyone.